Okay, so the first trig equation that we're actually going to factor is going to be sine squared x minus sine x minus 2. Notice that this looks very similar to x squared minus x minus 2 equals 0 if I had just removed the sign. So we're going to solve it exactly the same way, except for instead of just having an x, now I have a sine of x. So I'm still asking myself what multiplies to negative 2 and adds to negative 1. Once I get those factors, then I'm going to break up my sine squared and say, okay, factors of negative 2 that add to negative 1 are going to be negative 2 and positive 1. So I still factor it exactly the same way I would have factored it if the signs weren't there. I just make sure that whenever I'm writing an x, I have my sine function with my x. So from there, I'm just going to take each one of my factors and set them equal to 0, and then solve solve these equations just like we would have solved the previous trig equations. So I'm going to add 2 on both sides here, which leaves me with sine of x equals 2. And then I ask myself, okay, where on my unit circle do I have a y value of 2? And again, I'm looking for my y value because I'm asked to find a sine, and sine is my y value. When I'm looking at my unit circle, I notice that there aren't any y values of 2. I also notice that my biggest y value is 1, and my smallest y value is negative 1. So in this situation, I'm looking for a number that's outside of my range, which means that I'm not going to have a solution. Then I'm going to look at my other side. I'm going to subtract 1 here so I can get sine all by itself, because I remember that I always want to get the trig function isolated on one side. So now I have sine of x equals negative 1. And when I'm looking at my unit circle, I need a y value of negative 1, which is going to end up being this point here, which has a coordinate of 0, negative 1. And if you remember, the radian value there is 3 pi over 2. So my only solution for this problem is 3 pi over 2.